Howdy students, this is going to be a video that talks about the standard heat of formation. So we're looking at another delta H, but instead of a physical change like solid to liquid or liquid to gas, we're looking at a enthalpy change for a actual chemical reaction. And so our symbol here, delta H, still stands for enthalpy. Which is heat, but then we have this subscript F with a superscript little degree sign, which stands for the heat of formation. So we're forming some sort of compound, which usually requires some sort of chemical reaction. So a couple things to know when we're going to compute these problems is that delta H formation, enthalpy of formation of a free element in its standard state, is 0. So free elements. That might look like magnesium as a solid because that's its standard state, or diatomic oxygen as a gas, which would be in its standard state. What would not be in its standard state would be something like iron, but as a liquid. If we had molten iron, that would not be a good example of a free element in standard state. So if we do have those, the value of enthalpy is 0. This is another way to calculate delta H for a chemical reaction. So here's our equation for the day. The delta H, and I'm going to add this little F with a degree sign, F naught, equals the delta H of formation, enthalpy change formation of products minus the delta H formation of reactants. So the shortcut would be delta H for a chemical reaction is P minus R, the products minus the reaction. Now, you'll also see sometimes this sigma sign for the products minus the sigma for the reactants, meaning you have to take the summation of all of the products and subtract it from the sum of all the reactants. Sometimes we're going to give you a table of these values, so you just need to find them in the table that we provide you. First example, we're going to calculate the delta H, and I'm going to add this little F. We're going to calculate the formation for the following reaction. We have calcium carbonate as a solid, and we're forming calcium oxide, solid, plus carbon dioxide as a gas. I'm providing you with a table of values for delta H. So, delta H is going to equal all of the products minus all of the reactants. So my products here, I'll go ahead and write in green. For calcium carbonate, we had a negative 1207.0 kilojoules per mole. Calcium oxide, we had negative 635.1. And for carbon dioxide, negative 393.5. So for the products, which is on the right side, I've got my calcium oxide listed here. And then over here, I have my carbon dioxide. And I'm adding those together because it's a summation, all of the products. And you'll notice that I put those in brackets here. Minus all of the reactants, which I only have one reactant. So here's my calcium carbonate. So I'm going to add everything for the products, subtract everything for the reactants. My final answer here is going to be 178.4 kilojoules per mole. If 1 mole of reaction takes place, then I'll have 178.4 kilojoules for the heat of formation, the enthalpy of formation. And we have one more example here. Calculate the heat of reaction for the following reaction. Heat of formation, we're looking for delta HF. We have hydrogen gas plus oxygen gas yields water. And you'll notice that we have some coefficients here, some stoichiometric ratios. So that might play a factor here as well. So products are over here on the right, and reactants are always on the left. So if I'm doing products minus reactants, well, I've got one product And I have my table of values over here, but I only have H2O listed. I don't have hydrogen or oxygen listed. So if I'm doing products minus reactants, well, the negative 241.8 comes from H2O, and you'll notice that I am multiplying this by 2. This is different from the last example. I'm going to multiply 2 because I have 2 equivalents, 2 moles of water that is being produced. I'm going to subtract it from the reactants. This would be hydrogen and this would be oxygen. And you'll notice that these are both 0. So why is that? Well, remember that hydrogen, H2, as a gas, that's its natural standard state, and this is an element. O2 as a gas. These are free elements, and they're standard states. So these both get 0, and they're actually going to be crossed out. So for this one, all we have to do is the first one, multiplied by its coefficient of 2. Final answer, negative 483.6 kilojoules per mole. Now, one more thing I'll say before the video ends is that when you get a negative delta H, we talked about this, this implies an exothermic reaction. If you had a positive value for delta H like we did in the last problem, that would be an endothermic process. Okay, something to remember there.